Welcome on Cool Paradigms. Why does time exist and special cases to reverse time? This text is also a response to the all too common assertion, whether provocative, ironic, or naive, time does not exist. We live in a four-dimensional space-time world with three purely geometric dimensions, for example, x, y, z, in an orthogonal coordinated system, and one temporal dimension, usually abbreviated as t, a dimension that is considered, unlike the other dimensions, to only be traversable in one direction. In practical terms, in our complex world, we cannot go back in time. That being said, it's necessary to ask three fundamental questions about time. 1. Why does it exist? 2. Are there real universes in which we can go back in time? 3. Why can't we reverse time in everyday life? So, point number 1. Why does time exist? It's first necessary to understand that time, although regarded as the fourth dimension of our real world, is not as intuitive as one might think. We have the impression that it flows, and that it possesses a flow rate that varies depending on our objective, subjective perception, and so on. But these perceptions are deceiving and do not help in grasping the true nature of time, with its imperative existence and necessity in our physical world. The mistake we generally make is to focus on time as an intuitive basic dimension. Unlike distances, which are palpable, time is a psychological abstract dimension in the sense of being intangible, fleeting, requiring complex mechanisms for precise measurement. Adding to the confusion, it's the official fourth basic dimension of the spatio-temporal universe in which we live. Therefore, we have the false impression that it cannot be replaced, for example, to more easily justify why it exists through a more intuitive entity. Well, in fact, we can replace it with something more intuitive, more imperative and tangible: motion. Motion defines time very effectively because it encompasses it. Indeed, there are no possible motions without their displacement occurring within a certain interval of time, meaning length per unit of time. Since motion is more tangible and intuitive than time, we can easily demonstrate the reason for the existence of motion in our universe, and in doing so, also demonstrate the reason for the existence of time. In other words, a world made up of material entities in three dimensions x, y, z can only exist, and even more so be observed, if these entities can move. It is for considering this motion in the form of acceleration and velocities that the concept of time emerges. But not the other way around. This means that motions in all their forms are a fundamental expression of our world, from which arises the essential existence of time. Although it's more practical to use basic units of length and time, like meters and seconds, to describe and measure these motions, rather than using units that directly represent motions, such as velocity and acceleration, and then extracting time, which is not very practical as a concept reversal. A quick precision: we mainly speak here about the most intuitive definition of motions, like the one you can use with your hand for a free subscription of this channel. Time is also relatively abstract and fleeting, whereas material entities in motion are very concrete. This, for simple reasons of practical understanding, further emphasize the conceptual primacy of motion over time. Although, in a purely mathematical context, one could argue the opposite because the t-axis is very practical for performing calculations. But these are generally not, and often by definition, the most concrete element of a world. One can also be convinced of the primacy of motion over time in another way. For example, motion is absolutely necessary for the measurement of time. From a sundial and the mechanical clock to the atomic clock, we always measure time through motion, vibrations, and transitions, which are forms of repetitive motions that, for greater precision, must be increasingly rapid and regular. A global universe in which time and therefore motion does not exist is impossible, since we exist and are capable of motions. In other words, for such a universe to exist, there would either have to be absolutely nothing in the infinite three directions, that's no motion and no way to measure time, or the full universe would have to be completely static. Yet again, since we are part of the global universe and observe that it moves, a completely static or entirely empty global universe is both absurd and impossible. Point number 2. Are there real micro-universes in which one can go back in time? Yes, if the concerned micro-universes are sufficiently simple. Let's assume a universe composed solely of three mechanical switches A, B, and C capable of being in only two different states, namely 0 and 1. Initially, in the first state of our experiment, the switch's display is 0, 0, 0, then move to display 0, 1, 0, then move again to display 0, 0, 0. Well, a macro-universe composed solely of these three switches returning to their initial positions also undergo a reversal in time, if all its conditions are exactly as they were during the first state. In the context of this micro-universe, there is no means to differentiate these states, nowhere and here, no way to count anything independently of the three switches and so on. It's an entirely theoretical scenario, but it makes more sense if a video is played in reverse. All the pixels on the screen replay the different states in reverse, literally rewinding time in the micro-universe of the screen by reversing the states until presenting us with impossible situations in the real world, like a broken egg from a fall reconstructing itself to return to the hand of the person who broke it. Point number 3. Why can't we move through time in reverse in most real-world situations? Because the reality is too complex. However, if in a space bubble large enough, at a given moment we could reverse the motion state of all molecules to put them back in the same state and position they were in a few seconds earlier, we would already have a sort of very convincing local time reversal. For example, the reconstitution of an egg from its broken and flattened state in a pan. Relativistic note. It's easier to have an intuitive understanding, albeit very partial, of the relativity of time if time is first perceived as motion. This is because we are accustomed to seeing motions change in magnitude due to the action of force and the object involved, rather than being directly perceived through clocks, which by definition have been designed to be as stable as possible to provide the maximum accuracy to measure time. First conclusion. Time exists because motion exists, and motion exists because a material universe in 3 dimensions without any motion is as absurd as a completely empty universe, both of which are even more absurd considering they contain observers, like ourselves. Additional observations. Motion always imply covering a certain distance over a certain period of time. It should be noted that in a certain conventional spatio-temporal reference frame, with distance and time situated between the end of the scales, meaning between 0 and infinity, excluding the limits, and for simplicity we take the practical reference distance of 1 meter with a reference time of 1 second. By comparing these two unit figures with each other and with the end of each scales, we obtain a single realistic motion of 1 meter in 1 second. 5 cases of immobility, no motions. 2 cases of impossible infinite speed and 1 case of indeterminate speed due to an infinite distance covered in infinite time. Denying time is also denying motion, and good luck with that. Second conclusion. One can simulate a return in time provided that the object in question is very simple. It is sufficient to reassemble the object as it was in its primordial state. And thanks to its digital nature, the computing world, particularly considering screens, is, in a video context, allowed the retrieval of initial screen state, passing through all intermediate stages, thus performing the equivalent of a time travel in the micro-universe constituted by the screen pixel. This enable us to visualize actions that are impossible in the real world. Psychological generalizations regarding time. Why do we often find phrases like time does not exist with 1,560,000 results mentioned on Google as of September 16th in 2023? This is absurd given that motion exists and multiple possible answers are possible as why it's like that, and here we have a few of them. Time is an abstraction relative to motions, meaning that it's an attempt to break down motions into two parameters. The first, very concrete parameter, is the distance traveled. And the second is time, which is an abstraction derived from motions and is measured by standardized motions. For example, by making mechanical chronometers, so we can measure the non-spatial parameter of a previously unknown motion by comparing it with the non-spatial parameter of another known standardized motion. The number we obtain, for example, are seconds, which are abstract units. We cannot touch, see, or sense them independently of an object or particle in motion. As a result, time is more difficult to grasp than distances like meters, and when general relativity informs us that time is relative, we doubt even more. However, relative does not mean non-existent. Actually, quite the opposite, like existing and complex at the same time. Time defined in our Western societies often oppresses us, especially in the context where many obligations are present. We must be on time, wake up in time, and so on. This leads to a quite understandable frustration, especially when the pragmatic concept of time is well understood. We never seem to have enough of it. Time is often frustrating because we cannot objectively rush it, stop it, or slow it down in our daily lives. And of course, when we think about trying to influence time, it's usually to gain some sort of advantages, like the possibility of making up for lost time. But here's some good news. Even though we can't change the overall flow of time, we can change the relationship we have with it. For example, by trying to speed up our actions and perception, we subjectively find ourselves in a world where time seems to pass more slowly, which is generally pleasant. The illusion of an eternal present without memory of the past or vision of the future. An eternal present that wouldn't need time because it's always there, present and timeless. Yes, it's always there and doesn't need memory or anticipation to exist. Yes, and yet it moves. It changes everything. Congratulations! You had enough interest to get here, and if you like these sort of videos, you can subscribe for free. It takes just a few seconds and can save you a lot of time with interesting ideas coming soon. And here is some music to give you some more time. Thank you for watching!